a software to be built for any business, what we generally do is like, as I discussed earlier, stakeholders we have, and then they propose management, project managers, that I would like to make a website for this business. And then the second step, it comes to this picture. As you can see, initial phases, a couple of things are there. First of all, stakeholders, they deal with money, how much I'm going to invest there. Project managers will be there regarding resources, and then scope, status, functional requirements for that will also come from users ultimately, who will be using that software. And then business analysts, they will identify, okay, these are the functionalities that we'll be having on the website or software, and will collect all the requirements and document that. And once these are done, okay, this is the requirements for the website, or a business, let's say a business for a product based site or a marketplace like eBay. So once all the requirements are there, they will have the problem statement. They will discuss with developers, okay, these are the functional requirements and non-functional requirements. Functional requirements are like, you can log in, you can select product, and then you can add it into cart, and then you can purchase that is functional requirements. Non-functional requirements is like, they want to do the purchase very quickly and simultaneously. I mean, how many users should be allowed to connect the servers, okay, and do the transactions. All this will come non-functional categories. And then what developers does, or architect does, and there are two things that will be there. One is like designing the application, designing the database. So both has to be interacted with application team and database team, database design. So I will discuss about the database design part. So for database design part, there will be a problem statement that has to be written. It's a clear statement that is concise, and it has clear information about what are the nouns and the verbs, attributes, characteristics of nouns. All this will be documented, and that will define problems or requirements, functional requirements and non-functional requirements. We can consider this student will be participating on exams, okay. So this is kind of thing we can consider as problem statement. And noun is their student, and then exam is noun, participation is a verb, and then there will be characteristics, and that will be defined in the problem statement, like which semester, okay, for the exam, and then which academic year, what's the name of the student. These are the characteristics or attributes you can consider for student. Once we have the problem statement, we will design the conceptual diagram. And once the conceptual diagram is designed, database architect will interact with the management that whether this is the right design. So everything will be discussed. So this is kind of not a physical implementation, but the logical implementation of the system. And there will be back and forth with management, business analysts, project managers, stakeholders, to make sure all the requirements of functional and non-functional are covered here. So we will see what are the methodologies of database design. First thing is ER diagram. So this is nothing but a graphical view of business processes. So business process will be there, and then it will have graphical representation of business process. and then from there we will implement ultimately the database, which is like in SQL Server database tables will be designed. So the first part is designing the ER model from the problem statement that will have all the entities. We will discuss about the entities, identifying representing entities there, and then their relationship. And once it's done, then we will move on to implementing the database design, which involves creating tables, implementing primary key, foreign key, unique key, null values, other constraint. Now all this will be also there in the problems statement, but not visually. Everything will be shown that way. It's just graphical representation, and main thing is to get the idea. It will not have specific sign for that. We will understand from the graphical view that this is what it means. So let's move to the ER diagram. So this is an ER diagram. On the right side we can see what it will represent is like the entity. Entity means noun, and the real the database design in SQL Server, what we understand is table. So how table is identified initially, in ER diagram it's considered as entity, and we pick up the nouns and put it there. This is noun, employee, department, employee. And then the relationship is employee works on, department. So association is works on. So this is a verb. So we put it there for the relationship or association. And the entities are represented in a square box or rectangle. I would say rectangle. And then oval is for attribute, and then diamond shape is for the relationship, and lines are there to link them. Now a couple of things we will discuss later on, but just initial idea is this for ER diagram. So just to review, entities are there, which is noun, employee, department, relationship, works on. Okay, that is the main part of it. And attributes will be represented by oval shape. Now to understand it well, the terminology, what is entity? So entity's concept is like on employee table, King is an entity. Okay, and then any name that is there, a person, individual person, John, Mark, these are all entity. So the table actually, though we are saying entity, actually it's called entity set or entity type. Entity set is like it has collection of entities, and collection of entities means collection of employees for employee table or employee entity set, entity set. So King is one, and then Mark is one, and John is one entity. Same for department. So department physics is one entity, and then chemistry is one entity, and math is one entity, like that. Generally saying, primary key normally doesn't get displayed in entity relationship diagram. You may see on some books they underline that, which represents primary key, but this is not necessarily required. Some of the books, as I mentioned about Cronky, he doesn't underline that way to identify the primary keys. Now let's see how to design a problem statement to ER diagram. So problem statement example is like the example that we already saw. Employee works on departments. Now from there we are getting employee verb, department verb, and then works on, relationship is works on, and then attributes. Let's consider anything, employee name, salary. This will be all attribute that will be coming here as oval shape. So there's a couple of properties that we'll be seeing in the ER diagram. So first thing is cardinality of relationship. What is that? So whenever we have entities that are on relationship, so the number of occurrence in one entity is basically cardinality of relationship. So let's see the example. We will be able to understand. So how many times employees occurring on this relationship? What will be the degree? Which implies like one employee can work on one department. That can be one situation. So that is participating only. Max is like 1 on this relationship. So one employee can work on only one department. So and then one department can have only one employee. If that is the relationship in both ways, then it's called one-to-one relationship, cardinality. Then second thing, we have one-to-many. So if we have relationship that many employees can work on one department, so how they're participating on that on the relationship? So many employees can work on one department. So on the other side, if you consider that one department can have many employees, but it's from one way. So as you can see, like it could be you can have a different requirements. Just as an example, that many department can have one employee. So one guy can work on many departments. That could be one option. And you can say one employee from in terms of employee. This design will help you understand, which is not logical, just to explain you what is that concept. So this is not a real life concept, that a one-to-many relationship in other way. So many first one, which is logical, that is many employees can work on one department. That is many to one relationship. You will hear that one-to-many relationship. That is also one-to-many relationship. On the other hand, it could be, which is not factual or logical, that one employee can work on many departments here, but one department can have only one employee. So whenever you have one-to-many relationship, there are two ways that you have to consider. From one side, it's many to one, and on the other side, it's one to one. So that's when it's called one-to-many relationship. Let me explain. This is a little complicated. So for now, I would say with this, as you can see the data here, that many employees we have can work on one department, 20. So here many is there, and one department can have many employees. So it's not one employee can work on only one department. So this is called many to one relationship. Another one is many to many, which implies one employee can work on many departments, plus one department can have many employees. Both way it's working. So let's say I'll show you another example. So if you see this, it will be easier to understand. So one employee can work on one department, one-to-one relationship. It's both way. One employee can work on one department, plus one department can have one employee. This is called one-to-one relationship. One-to-many is one employee can have many departments, okay, or one employee can work on many departments, or many employee can work on one department. Okay, either if one constraint is true, then it will be called as one-to-many relationship. And then other one is one employee can work on many departments, or many employee can work on one department. Both constraints are true, then it's called many-to-many relationship. So just whatever I said, just try to implement that and you will understand this. So the implementation will look like this. If you see the first one, that is one-to-one relationship. So the table will look like this. Okay, one employee number 1, name A, works on 1, department 1. Employee number 2, B, and department number 2. And C, work on department number 3, D, 4. So there is no repetition that employee 3 can work on 2 departments, or department 1 can have more than 1 employee. So department 1 is like one time. Okay, we are not saying department 1 employee 2, department 1 employee 3. It's not like that. So one department, 1 employee. Okay, that is the relationship called one-to-one relationship. If you see many-to-one relationship, this is what it is. So the table structure will look like that employee, and as I said in the class, that whichever side has a 1, the primary key from that side will come to this side where we have many as a foreign key. That is for implementation. I will discuss about implementation a little later on. But you have employee, you have department. Many employees can work on 1 department. One department can have many employees, but it's not something like 1 department can have only 1 employees. So you can see here employees are there, and then they work on 20 department number 20. Okay, but so they can work on different departments, but a single employee cannot work on 2 departments. Okay, that is not here the logic. Then if both are true, then it would be called many-to-many relationship. One-to-one, one-to-many plus many-to-one is called many-to-many relationship. We will see many-to-many in the next slide. So for this one, it has many-to-one relationship. Many employees can work on 1 department. So you are seeing many employees like 7499 and this 2 working on department 30. So many employees working on 1 department. 30, 20 has several employees. So foreign key came from department table, where you have one side as a foreign key. It's a primary key on other table. Next thing is many-to-many relationship. How does it look, many-to-many relationship? So in many-to-many, you have 3 tables to implement that. Many-to-many is like the logic is 1 employee can work on many departments, okay, plus 1 department can have many employees. 2 statements true together. 1 employee can work on many departments, and then 1 department can have many employees. Both together is called many-to-many relationship. How it looks like? So you can see here that we have employee table, employee information, department table, department information, and employee 1 is working on X1 department. Employee 2 work on X. So multiple employees are working on 1 department. On the other hand, you can see that multiple employees working on or same employee working on 2 departments. So that is many-to-many relationship. So whenever you have a ER diagram, as you can see on the top, you can have one-to-one relationship. So first of all, you need to identify the entities, and then next you have to put the relationship and then attributes, and then you have to define the cardinality. And what is the cardinality there? That is it can be one-to-one relationship, one-to-many, many-to-one, many-to-many. So it will look something like this. And then how will you implement that as a table? So whenever it will come to implementation, so the data is like this. So one-to-one relationship can be saved as this one. It's totally up to you, or sometimes requirements of the system. But whenever you have one-to-one relationship, you can have one table, since it's not repeating, and you can represent the information this way. So one employee, one department, two employee, so there are no repetition, so it can be simple. They can be together, employee and department, and you can call that out employee department. Another option could be, so you can have employee table separately, department table separately, and then you can have third table where you have, this is one option, but preferably the first one is better. One-to-one, keep them together, okay, in one table. That is one-to-one relationship. It's easy to pull information. Other way could be like just like whatever we saw, bringing the primary key from other table. You can do that way as well for one-to-one. So three options can be implemented there. For many-to-one relationship, what you will do, as I said, so this is the design and this is the implementation of the data. So database design, okay. So when you make the table, you have to bring the primary key from department table to employee table as a foreign key. So department number is a foreign key here, we can see, and this is actually the primary key of the department table. So that is the implementation of one-to-many relationship. And how do you do many-to-many? Whenever you see many-to-many, this will be implemented as a table, this will be implemented as a table, and there will be third table there, okay, and that will have a primary key from each table, okay. And then you can assign a surrogate key for this number. You can put it there, serial number, and then 1 2 3 4 5 6 7 8, like that. It will be just to identify each row uniquely. So that will be the case. Another terminology is degree of relationship, okay, so which is like how many entities are participating on the relationship. Here you can see employee and department, they are participating on the relationship, so it's called 2, degree is 2, okay. So you can have like another entity in the relationship, let's say semester, okay. So if that participates on this association, it will be called trinary relationship. So and degree will be called as 3. Next representation is total participation, partial participation, okay, which is represented in database design. You can understand like the null value, whether a null value is there or not. That is one thing that will be represented with total participation and partial participation. So we will see how it works. So as you are seeing on this table, employee table and department table, everybody has a department. Nobody is there like that doesn't have department. So everybody, all the employee works on departments, all the employees. So nothing gets like, okay, this entity will not participate, he doesn't have any departments. It's not like that. So that is called total participation. So all the employees have departments. So each employee, you can say that each employee has a department, or each employee belongs to a department. So that is total participation. Partial participation is a department may have no employees. Okay, this has employees, 10 has employees, 20 has employees, 30 has employees, 60 doesn't have any employees. So it's partial participation. So how it will be represented? For this one, for employee table, it will be double line. Department, it will be single line. Okay, I didn't put it there, I can just put it that way for you to understand. So That is about total and partial participation. Another feature that is represented in ER diagram is cardinality ratio min max. So here you can see on ER diagram you have 1 dot dot 1 and 0 dot dot n. What does that mean? So here it represents the null value. So 0 implies here that it will department can have no employees. Okay, so that is what it is like, and dot dot n implies up to like multiple department can have multiple participation. So let's see the example here. So here we can see for employee side 1 dot dot 1. So here what it means is like there will be one employee minimum participating on this relationship. Okay, one employee will work on one department. So first one is implies minimum 1, so nobody can go like without department. That is 1. And next one implies that max one employee can participate on one department. So first one again, so 1 means employee cannot have no departments, and one department can have one department. So that is what it means by 1 dot dot 1. Next thing from other side is 0. So that implies that department may not have any employees, so that is 0. And department can have one department can have many employees. So on that relation it can participate multiple times, or it may not participate at all. And here like on this relationship at least one has to participate. That implies it cannot go empty on the relationship without relationship. So employee has to have a department, that is 1. If it would be 0, it will allow the null values. Okay, so employee would have no department. We would see here null values, but we are seeing at least everywhere it has a department number, so that's why it's 1. And then the next one is on the participation max. It can participate 1, so it can have only it can belong to only one department. So that is cardinality ratio min max. Now there is another representation which we can understand the cardinality ratio min max. So here in this picture you can see the participation on association. So these are all in entities, like entity 1, entity 2, which is like employee 1, employee number 1, employee number 2, employee number 3, employee number 4. So everybody, employee number 1 belongs to department 1, employee number 2 belongs to department 2, employee number 3 belongs to department number 1. Okay, so everybody is participating, but we are not seeing, so that's why it's 1. So you can see all are participating on that, on this relationship. So 1, and then 1 cannot have you can see it's going to one direction only, but employee, there is no line from here to another one. So E1 R1 relationship 1, so it has only 1, and then E2 R2. Okay, so it has only max 1 department, so it's participating on one relationship. Whereas department 1, it has this doesn't have any department employee at all, so it's 0. So minimum is 0. It can have 0. So no, it's not participating in the relationship. That implies it doesn't have any employee. And then it can have n. It can participate on multiple relationship, which is D1 has employee 1, D1 has employee 6. Okay, D1 has employee 3. So it can have n. Lastly, if you want to understand the more details of the concepts, there are two books. One is Fundamental of Database Systems by Ramez El Masri. Another one is David Kroenke. So you can check both the books. This version is 10th. That's what I read, and then 4th version of this book I read. So you can check out the latest one or whatever is available in PDF. Thank you.